So I'm not a climate scientist, as I said, and we heard that the Assemblyman is not either, but we have next a climate scientist. I'm very pleased to introduce Professor Sonali McDermid, climate scientist, it says right here, assistant professor of environmental studies at New York University. Professor McDermid serves as climate co-lead for the Agricultural Model Intercomparison and Improvement Project, researching intersectional solutions for environmental and food security across sub-Saharan Africa and South Asia. She obtained her master's and doctoral degrees from Columbia University's Department of Earth and Environmental Sciences and completed a NASA postdoctoral fellowship at NASA Goddard Institute for Space Studies.
Thank you very much for being here. This is kind of inspiring. And I'll say the Assemblyman did a great job with the facts on climate change, very much so. So now I get to talk to you about the uncertainties, actually, about the known unknowns, as I say here, that keep me up at night as a climate scientist and is more of a reason, I think, that we should do something than even what we know. Now, I'm going to preface that all the plots and graphs and figures, yes, I will show figures, that you see here tonight were created through government-supported research. And without that, we would not even know that we didn't know things, which is not a good thing for climate change. Now, as the Assemblyman said, and Mark has said now, yes, the last 9 out of 10 record-setting years actually have occurred since 1990. And it's not just in the data, it's something that we feel. Most of us just spent most of February this year feeling guilty about enjoying the warmer temperatures, believe it or not. And so temperature, right, that is something that we know. That's something that we feel and that climate scientists actually have a great deal of confidence about. What you're looking at here are the temperature predictions for the best case and worst case climate scenarios. And yes, there is warming even in the best case climate scenario. Now I want to call your attention to a couple of things. I don't know if the cursor works here, I think it does. These numbers on the sides of the plots, those are the number of models that were used to create these figures, okay? Those dots that you see on the plot, that shows where the models agree, where we have a lot of confidence about what's changing and how, in this case, temperature. So we have a great deal of confidence on temperature and how it will change. But up here, you can see kind of the North Atlantic, you can see those lines, those hatch marks. Those are areas where we actually don't have a good signal from the noise. We're not as confident about the results there. Now, this is temperature. This is what happens when I go to rainfall. You see a lot fewer, right, a lot less of those dots and much more of those hatch marks, those lines. We have a great deal of uncertainty in rainfall. Okay, we know that there are some changes that we can expect, but this poses a problem for things like impacts and severe storms that we care so much about. And so I show this to illustrate a point, right? Those figures took government-funded research, not just from the United States, but those are 40 models, roughly, around the world through their own governments that were supported to create that. Science has a huge burden of proof. We require a lot of data points, a lot of models before we can conclude anything, and that takes time. Science can be slow. Now, that being said, our daily lives respond much faster, and therefore we're much more susceptible. It only takes one extreme event to incapacitate entire communities. Case in point is Chennai city in southern India, where part of my family is and some of my research is. And this is what it looked like in the fall of 2015. Completely inundated. They had the most rain they'd ever seen in a long time. That's a picture of the airport. They had to shut it down. We didn't make it out when we were supposed to. Now, there were multiple reasons for this storm. There was a big El Nino that had occurred, the biggest ever recorded, potentially. So that changed rainfall patterns. In addition, the Indian Ocean sea surface temperatures are rising faster than anyone anticipated and than any of the other ocean basins. And that gives more moisture to the atmosphere, right, to cause rainfall. On the bottom, you see this plot. I apologize, it's a bit stretched, but these are monthly averages over a 30-year period, and November usually sees the most rainfall. That blue box, shows the extent of variability, and November 2015 was up there. It was actually about a year's worth of rainfall in the span of about 2.5 weeks. And I show you this because this is a personal issue to me. I was there for this. These are pictures taken from the vehicle that I was in. We were studying an agricultural adaptation project down there, and we couldn't get out to our field sites because the roads looked like this. In fact, there was water coming into the vehicle. And I'm sitting there thinking to myself as a climate scientist, God, if this is anything like what we're anticipating for future climate change, I don't need to see anymore. I don't need to be convinced anymore. We need to act, and we need to act now. This was terrifying. And so, as scientists, we don't like to over-predict anything. We don't like to overstate anything. And rain is not the only source of uncertainty. Ice is too. And sometimes that leads us to under-predict things, underestimate them. We did this in 2006 when Greenland started melting faster than we anticipated. It happened again in 2012 when we realized we had underestimated melt. And then lastly, in 2016, we realized yet again we had underestimated the ice melt, and it will be that same thing in 2017. Our models are not keeping up. And so we have to think about the implications of this. These boring plots are sea level rise, again, under the best case and worst case climate scenarios. But what I want to draw your attention to are the numbers on the side. This is the possible range of sea level rise based upon all these independent measures, these different models. And you can see they're quite big. If you're a coastal planner, right, or infrastructure planner or policymaker, how do you make a decision based upon ranges that big? And I think I answer that question with a question of my own. How confident do we need the science to be? How much more science do we need in order to start thinking about how to build resilience in our communities? How dependent is that upon additional science, right? This is a picture of the Exploradores Glacier in northern Chile, which I visited in 2012. And being at a glacier is one of the most emotional experiences because at the same time you feel so endowed with this landscape, this beauty, and at the same time you're mourning a loss. Why? Because that trim line that you see there, that's where the glacier used to be. In fact, where I'm standing, where I'm taking this picture from, was where the glacier used to be, and you can see forests growing over that region now. And when you think about that, you have to think about the implications. Picture of Jane's Carousel in Brooklyn, many losses here as well too, as for Superstorm Sandy. And in the future, with sea level rise, it may not even take a storm that extreme to cause the same kind of response that we saw during that event. Now, I say this with some caution. As a climate scientist, we don't like to attribute any one event to climate change. We need more data. We need more model simulations, right? We can't conclude anything. However, things are changing fast in the field. In fact, in some places like Australia, they are now able to attribute quite well their extremes, their droughts. They're actually going through a massive one right now to climate change. It wouldn't have happened if climate change wasn't a problem. And this presents a problem for us, for science. We make predictions of the future based upon how much we know about the past, all of our past accumulated data. And right now, we're experiencing things for which we have no precedent. We have no background data. We have no historical evidence of this change during the human period. These plots are called the Great Acceleration. And don't worry about what each individual plot is, but what they all show is this rapid change, this rapid increase in almost every metric we can think of, from energy use to nitrogen pollution, right, to land use over the late 20th century. Things are changing so fast in some cases that the science can't even keep up. At this point, we're losing mammals at 14 times the background extinction rate. In fact, we might lose these species even before we get a chance to study them. And we might be forever uncertain about their role in our ecosystems, in our environment, and this world that we share. And so, I'll end here on a few points. One, of course, climate action is necessary, and now more than ever. Not only because of what we know, those temperature increases that we feel, but also for the uncertainty that we don't know and how bad it could potentially get. Why do we buy insurance? Not because we're certain anything that happens, right? But we buy insurance to guard against our aversion to loss, right? Demands that we do that. We also want to take action because of what we're missing, a chance to get to know the great biodiversity on this planet and what we'd rather miss, such as sea level rise. And frankly, because to not do anything, even when we're uncertain about it, is just completely unethical. We need to keep pushing forward because we know that we can come in at the bottom of those thresholds, and that is our choice to do so. And the last thing that I'll say is that the reason that we know any of this, even the uncertainties themselves, is because of publicly funded research. It is essential to deliver critical, salient, and objective and transparent information in rapidly changing conditions. And yeah, there are lots of outlets now for research, but none of them holds the accountability that government-funded research does. And in fact, most of climate science will not ever be done and cannot ever be done without government-funded research. So thank you.